In this video, we're going to demonstrate a very simple method for determining the power profile required for the DE726 reference horn to create an electronic field with a strength of 2 volts per meter independent of frequency at a distance of 3 meters. To do this, we proceed into the advanced section and load the DE726 data from the advanced data directory. Next, we invoke the simulator. Once the simulator is opened, we invoke the monitoring plots. Then we recall the gain data resident in register 4 by positioning to 0, 0, or the peak gain, and we have the gain profile. It's within this profile we wish to modify the isotropic power at 3 meters to create a constant 2 volts per meter. We first create an ideal isotropic antenna by connecting the 2 ports directly together within the simulator. We're going to invoke calculate antenna volts per meter, but first we must set the path loss. In this case, it is 3 meters. Once the path loss is set, we invoke volts per meter. When we do this, the plot will change to linear and the minimum for the plot will change to 0. We're looking for 2 volts per meter, so we'll scale the plot to 5 volts, and we'll set the markers on the isotropic volts per meter. We can see that we have about 57 millivolts. We're going to increase the volt power until we achieve 2 volts per meter. We'll first set the power to plus 10 dBm and recalculate the volts per meter. Now we're going to try and change the power level to plus 16 dBm, and again we recalculate the data. Now we have a very small voltage. If we now increase the power level to 1 watt plus 31 dBm, we can see we are very close to 2 volts per meter. We're going to leave the power level at the set port to plus 31 and invoke the math icon. We're going to reduce the constant power required by the gain of the DE horn. To do this, we'll simply divide the isotropic power X by Reg 4. When we calculate power, we will have the required power profile. We're going to go back to dB and scale the power profile from minus 30 to plus 30. Now you will see the power profile. To create 2 volts per meter at 6 GHz, you would need plus 17 dBm. We can actually create a simple file in terms of this data by invoking S1P. We'll choose dB for dBm and we'll give the file a name, and we can see the output power is now resident. It's a very simple way to create calibration data for your DE horn. And this concludes our video tutorial for the power profile method for constant volts per meter. We hope this video has been helpful and informative. Should you have any questions or comments, please feel free to email us or give us a call. Thanks for watching.